Okay, Austin, I hope this helps. If not, still contact me or call me and I will assist you with any other questions. You probably remember back in class, I would ask you what's x squared? That's a graph of a parabola. The square root of x, if I ask you for the graph of the square root of x, that's going to be a graph that looks like the following. But when you ask for 1 over x, that also gives you a particular graph. You could pick numbers and plug it in. Always feel free when you're doing a graph to go ahead and pick x and y values. Since it's 1 over x, one thing we are going to notice, if you pick the value of 0, you get 1 over 0. And that is undefined. So that means that you are going to get a vertical asymptote right here. And remember, that means it will approach that value, but never cross it. If I pick the value of -1, we are looking at the value of 1 over -1, which is -1. So in your graph at -1, you also get a value of -1, which is right here. If you pick -1/2, that is 1 over -1/2, which when you flip and multiply, you get -2. So at -1/2, you get -2, which is going to be right here. If you were to pick -2, you're going to get 1 over -2, which is just -1/2. So your graph actually curves in the quadrant 3 when you pick your negative values for x. If you were to pick values for y, if I say, or pick values for x again, sorry. If you were to pick values for x again and pick positive numbers, say I pick 1/4, if you put 1/4 in, you get 1 over 1/4. And if you flip and multiply, you get 4. So at 1/4, your y value or your output is the reciprocal of that, which is 4. So at 1/4, I get this value of 4. At 1/2, you get a value of 2. At 1, you get 1. And then it's going to curve and get closer and closer to the x-axis. So your graph looks like this. So that's the parent function. And if you remember, if we do something with that +2, if I gave you a parabola that was x squared minus 2, that -2 is not associated with the x, it's the y, so it would drop it down 2 places in your parabola. It'd look like that. If I gave you the quantity x plus 2 squared, now it's associated with the x, and you move in the opposite direction. So your graph for this, the quantity x plus 2 squared, would be to shift it back 2 places and curve it up, if that is ringing a bell of what we talked about last year. So the actual graph that you are asking for, first of all, I have that 1 over x that I have in orange. I hope you can see this. I have the dark purple or whatever, dark blue xy axis. And if we graph just the parent function in orange, if x is 1, you get 1 over 1, which is 1. If x is 1/2, you get 1 over 1/2, which means the reciprocal, which gives you a value of 2. At 1/4, you get 4. At 1/9, you get 9. Let's see, 2, 4, 6, 8, 9. If I go with 2, you're going to get 1/2. At 4, you get 1/4, and so on. So your graph, well, that wasn't a very nice curve right there. But you get the idea. It's going to curve like this. Your other parent function, if you were to continue into the other quad, if you were to continue with negative x values, at 2, you get 1/2. At 4, 1/4. Anyway, it's going to curve something like this. So what we need to do in order to graph the blue, which is what you are wanting, is you want to shift everything to the left 2 places. So for an example, your vertical asymptote is no longer where we had it before. Is your vertical asymptote is right here on the y-axis. That's what it's going to approach. That gets shifted 2 places over as well, because if you look at it in the second equation here, the one you were actually looking for the graph of, if x is -2, when you put that into this equation, you're going to get 1 over -2 plus 2, which is 1 over 0, and that is undefined. So at -2 is now where you get a vertical asymptote. I don't know if your college professor is going to ask you to sketch in that vertical asymptote, but then if you were to put in, everything just shifts over 2. So this critical turning point right here of 1, 1 gets shifted over 2, and it becomes -1, 1. If you were to put -1 into this equation, you're going to get 1 over -1 plus 2, which is 1 over 1, and you get a value of 1. Now the same thing with this value of -1 right there. -1, -1, it gets shifted over 2 places, so it's going to end up right here. You're still going to have that same horizontal asymptote, but it's going to curve like this. Oh, that was a bad curve again. I'm not so good with my curves. So it looks something like that. So I don't know if the grids help you or not, but here's what's going to happen. You take this XY axis back here at -2, you will have that vertical asymptote. I don't know what critical points they are looking for, but if you pick this point of -1, you will get -1, 1. So you're going to get a curve in this quadrant right here. And if you pick the point -3, remember that's going to be 1 over -3 plus 2. So that's 1 over -1, which is -1. And you get this point 1, -1, which is going to be your turning point where you curve and you approach the line x equals -2 as a vertical asymptote, and a horizontal one, you will approach that x-axis, but you will never cross it. So I hope that helps. That's 7 minutes. So I hope I didn't bore you. I hope you're enjoying it up in Wisconsin, and this is the closest communication I can give you. But just know that I'm giving you a long distance hug. We'll talk to you later. Feel free to call if you have more questions. Okay, wait, I'm back. I just got your other text message. So your question was, what happens if you put a 2 in front of it? I'm going to go back to the orange again. Normally this is in class when I'd like to do the yellow. But you have your normal parabola here. If I just gave you y was equal to x squared, and you think about the table. If y is equal to x squared, I'm going to pick some values for x. So you have -2, -1, 0, 1, and 2. Remember, if you put -2 in and you square it, that's going to give you a value of 4. At -1, -1 times -1 is 1. 0 is 0. 1 squared is 1. 2 squared is 4. So if you want to grab that, I'm just going to do a rough sketch because I thought that grid got a little hard for me to look at anyway. So at -2, you get a value of 1, 2, 3, 4. At -2, you get 4. At -1, you got 1. At 1, you get 1. At 0, you got 0. And at 2, you got a value of 4. So yes, the parent function is this parabola right here. Now, I believe what your question is if your equation becomes y is equal to 2x squared. You were right. Does that make it skinny or does that make it a fat parabola? Oh, you should have just saw me. I sat there and stood up in front of the room. Nobody else is in here. And I put my arms up in the air and then I stretched them out just like you would have envisioned last year when you were sitting here with me. But I just did that and nobody was here to see me. And you can't see it either. But here's what happens. If we look at the XY table now, I'm just going to put a subscript of 1 so I know that's a different Y value. And I'm going to add it to my table here. So if we put in -2, what you are looking at down at the bottom of your table, you're going to take 2 times -2 squared. -2 squared is 4. And if you take that times 2, you now get a value of 8. So when you were back here at -2 on the x-axis, you have to go up to 8. 1, 2, 3, 4, 5, 6, 7, 8. So at -2, you get a value of 8. Then if you put in -1, -1, so you're going to have 2 times -1 squared. -1 squared is 1 times 2 is 2. So instead of having the coordinate point 1, 1, you get the point 1, 2. 0 is still going to be 0. If you put 1 in, 1 squared is 1 times 2 is 2. So now you have the coordinate point 1, 2. So I go x is 1, y is 2. And if you put 2 in, 2 squared is 4 times 2 is 8. So at 2, you get a value of 8, which is up here. So your parabola now looks like that. So what it did was it caused it to stretch upward. The higher that coefficient value, the higher up you're going to stretch. You got to reach up to get to that value. So I hope that helps now. And if you have questions, let me know. Now you have 11 minutes of listening to me. But once again, when I told you you got to stretch up, the higher that coefficient value is, you reach up. Guess what I did with my arms? Stuck them in the air and reached up. Even though you can't see it. I don't know why that doesn't help. Anyway, hope things are going well, Austin. And I will save this and get it posted to YouTube so you can watch it.